Hello, this is Maddie Chabab, and this is my video for my final project. I chose the microprocessor, and as you can see here, I have the entire connected microprocessor on this main page of Logisim. And then just before we actually go through and ensure that everything's running correctly, I just want to take you through some of the subcircuits. So here we have our program counter. We're just going to view that, and then basically we just have some adders here that are cascaded to ensure that we're actually going to increment through and run all of our instructions. And then the next subcircuit we have here is the FSM and output logic. So initially you're going to see, sorry, let me zoom that out, all of the output logic. And that output logic is being controlled based on the instruction bits here, B3 through B0, and then this FSM, which we will also view in greater detail. And then we'll just go back to the main. And then the last component or subcircuit that I want to show is the ALU, which is basically in control of adding and subtracting. So up here we have the subtractor, here's the adder, and then just some flags to indicate negative or overflow. And basically, because it's a very simple microprocessor, so we haven't built it to actually handle negatives and overflows. However, by using the carry out and bar out bits, we can at least indicate that an overflow or a negative value is happening due to that addition or subtraction, just so that we know not to really look for a reliable value here on the display for register A to kind of show what's happening in register A after the result of the addition or subtraction gets loaded back into it. So now that we've done that, we're basically just going to simulate. And before we do that though, I want to show just the instructions that the actual circuit is using. So this is based in hex. This is ROM from Logisim, and a ROM component, and basically the first figure is indicating instructions, the second one data, and then we kind of just have a more comprehensive chart showing these hex instructions here in our report. And so what I'm going to do is go through, basically just keep this output window up as we cycle through the circuit so that we can ensure that the correct functions are happening. And so we'll just get started with that. So let us simulate. Ticks enabled. So the first thing we should see is a 6. We see the 6, and then we're going to add 2, we get 8. Then we're going to try to add 9 to it, and you can see 9 goes through there. However, that's an overflow, so our overflow flag goes off. We're going to have a 1. We're going to load the 1 onto the output display, and so you can see it down in the bottom right hand corner. A 1 will appear there. Then we should get a 6. We see that. We're going to try to subtract 7. We should get a negative flag. That's correct. And then we're going to get a C. We're going to put the C to the output. You'll see the C on the output there. And then after that, we're going to add 1. We'll get a D. We're going to subtract from that to get 4. Add to that to get 4. Or add to that to get 8. We saw the 8 there. The 8's going to be sent to the output display. If you look in the bottom right hand corner, there's the 8. Then we're going to subtract 3. We'll see 5. We just saw that. And then it's going to cycle through until you have our last 3 on the output display. And then we can just stop that. So then just another note, the components here are falling edge, so we should see those changes as the clock goes from high to low. Just a couple other notes, we have the actual state bits up there so we can see what state it's in, whether that's fetch 1, fetch 2, execute 1, execute 2. And that is the microprocessor final project. Thank you.